Good morning, one and all. Today we present our project Spacex Falcon9 landing predictor using machine learning. Our team members are Amjad Kejaber, Tony John, Punya Lalu and Nisamuddin MJ. So let's begin. First of all, we have to import the libraries such as pandas using import panda as pd, numpy as np, matplotlib as plt, seaborn as sns. From sklearn, import the packages such as pre-processing, train test split, accuracy score, etc. like decision tree classifier. And we import the warnings, and we now import the dataset using pd.read csv, and we copy the path of our drive here, and we display the dataset here, so we can see the dataset is imported. To find the data type, we use df.info, and we can see the data types displayed here, and we use df.isNull.sum/df*100 to find the percentage of null values. So as we can see, the percentage of null values in the landing pad is 40%, and the payload mass is 5%, the others are 0. So we drop the landing pad because there is too many null values in this, and we display df.dtypes to see the data types in the dataset, and we use df.valueCount is used in different features to calculate the number of launches on each side, number of orbits, calculate the number of occurrences in the orbit, and the longitudes and latitudes, etc. So we use value counts in each of the features in the dataset. Next up, we use value count on the outcome and save it to another variable called landing outcomes. And in these landing outcomes, we can see several different outcomes such as true ASTS, true RLTS, false ALTS, true oceans. And this true oceans means a mission outcome was successfully landed in a specific region of the ocean. True ASTS means that the mission outcome was successfully landed in a drone ship, etc. Next, we create a set of outcomes where the second stage did not land successfully. For that, we use for_i outcome in enumerate landing outcomes.key and print that I and outcomes. So we have the values here and the outcomes specified here. And then we set that value into the bad outcomes variable and print the bad outcomes. As we can see, the unsuccessful landings will be displayed here: false ASTS, false ocean, false RLTS, etc. In the outcome, we create a list where the elements is 0 if the corresponding row in the outcome is in the set bad outcome, otherwise it's 1. Then we assign to the variable landing class. This variable will represent the classification variable that represents the outcome of each launch. If the value is 0, then the first stage did not land successfully. 1 means the landing is successful. And now we can use this piece of line to find the success rate of the landing procedure, and we use the following lines such as df of class.mean to find the mean success rate, and df of class.valueCount, etc. And we once again run df.isNull.sum to find the not null values, and we can see that the payload mass is 5 and the other values are 0. So now we use mean values to fill into the null values in this payload mass, and then we run df of isNull.num again, so we can see that there are no null values. Now we print the dataset again using df.head, and after the data preparations, we convert it into a CSV file for the data analysis, and then we use a descriptive statistics in the data analysis using describe function. And as we can see, there are many values such as mean, standard, and min max values. After descriptive statistics, we now follow into visual analysis. A visual analysis is a process of visual representations using graphs and charts, etc. So we use univariate analysis using the box plot. So we use sns.conplot of x is equal to launch site comma data is equal to df1. So we use the data in the df1, and we find the box plot of launch sites, the number of launches occurring in different sites such as SLC40, SLC44E, and 39A. So the maximum number of launches are done in SLC40. Then now we use bivariate analysis to visually check there's any relationship of success rate and orbit type. So we use the figure is set in inches of 12,8, and x value is orbit and y value is class, and data is used from df1. So the pellets actually are used in blue. So the following codes are written, and the font sizes are given, and the graph is plotted using the data of df1. Now we can find the success rate by year using the year function, and this function is used to extract year from the date given, and we use the same code such as figure.set size of inch 12.8. This is the size of the graph, and we set x-axis as year and y-axis as class, and the data is taken from df1, and the font sizes and other informations are given using this code. So the graph is plotted using the data from df1. The heat map is actually printed using this code sns.heatmap of df.core, anode is equal to true. Now we split the data into train set and test set. So here x values are given. Variable x is given the values of df1 dataset, payload mass, orbit, launch sites, flights, grid fence, etc. And the x is displayed. And the label encoder function is given, and the dataset is transformed into the integer, and we use as-type float64 to transfer the values into float values. And now y variable is defined, and the target variables is passed to the y variable, and the x variables we pass the features, and then we run the x test, x train, and y train and y test, etc. And the logical regression function is given, and we pass the x train and y train tests as parameters to this function, and we use the decision tree classifier models. We use different classifier models such as decision tree classifier, K-Nibus classifier, and random forest classifier. These classifier models are run on these X-train and Y-train tests, and the values are predicted. As we can see, the logical regression has the more FI score. The accuracy is more in the logical regression, so we pick the logical regression as the prediction model, and we import pickle and we save into the after running several tests on different prediction models, we arrive into the conclusion that the logical regression model has the best accuracy, and we import that file into the pickle file. After the best model is selected, then we create a web application and we integrate the model we built, and a UI is provided for the users where he has to enter the values for prediction. So for that we have created a HTML file where where the interface is made, and another server-side script where we can integrate the UI into the model we built. And then now we have to enter the values. So we have to this is the interface of our landing prediction web page. So we now enter the values. We have to fix the payload mass as 500. The orbit is set at Leo, and launch site is SLC 40. The longitude we can set it at 80.60. Set latitude were 28.60. Grid fins is not used. We can legs is also not used. So we can set the core block is 1, and the flight with that core is, we can set it as 1 also, and the core reuse count, the number of times the core has been reused, we can set it 0. So now we launch the code, and the output is launch was unsuccessful. And that is it. That is our model for predicting the Falcon 9 SpaceX. And that is it. That is our model for SpaceX Falcon 9 success predictors. The values we entered was not successful, as we can see. The dataset we have taken is from Kaggle, and the dataset is given is SpaceX launch data. So thank you everyone for listening. Thank you so much. Have a nice day.